This is section 7-1, Finding a Place to Live. The objectives of this lesson are to calculate the affordability of a monthly rent, to determine the relationship between square footage and monthly rent, to determine lease signing costs, and to calculate moving expenses. Here are some key terms that'll come up in this lesson. Most of them are fairly self-explanatory, and as a result, I have not included the specific definitions of each of them. But most of them you should be familiar with and know basically what they are referring to. So, where will you live? Where will you be living in a few years after you graduate from college and your education is over and you're beginning your career? You're going to find that housing expenses are extremely high depending on where in the country you are. Around the Boston area, they're very high. And some people are going to find that they're going to be forced to stay and live with their parents initially because of the high cost of rent and housing. So why do people rent rather than purchase, or vice versa? We're going to learn some of the advantages and disadvantages of each of these in this and subsequent lessons in this unit. So let's look at an example. Alex makes $61,992 per year and pays about 25% of his gross monthly income in federal and state taxes. He wants to find an apartment to rent and estimate how much he can afford to pay for rent each month, then determine how much money he will have after taxes and rent are paid. So we're looking at an example here. This is his gross yearly income. This is his income prior to any deductions, and we're trying to see what he can afford. What's the maximum amount of rent that he can afford? Well, the first thing we're going to have to do is convert his yearly gross income to monthly gross income, because he's going to be paying rent per month. So we're going to take his yearly gross income and divide it by 12 so that we can get his gross monthly income, okay? And we're going to find that that is equal to $5,166. Now, we're going to look to see how much he can afford to pay for rent each month. Now, there is a rule of thumb that one should not, as a maximum, one should only pay between 25 and 30% of their gross monthly income on rent, okay? So basically what we're going to do is we're going to go halfway between that and say, what is 28% of his gross monthly income? So we're going to take his gross monthly income, multiply it by 0.28, and we're going to find that he can afford to spend a maximum of $1,446.48 on rent. Now, we know that he pays about 25% of his gross monthly income on federal and state taxes. So therefore, we're going to take his gross monthly income, multiply it by 0.25, and find that he spends $1,291.50 on monthly taxes. Now, if we take the amount he can afford to spend on rent plus the amount he's paying in federal and state taxes and adds those two together and subtracts them from his monthly gross income, we get $2,428 as the amount that's remaining after he pays rent and his federal and state taxes. So this is the amount he has left for things like food, transportation, entertainment, and any other expenses he might have in the month, as well as savings. Now, let's look at example 2. Rufus and Maria have both been offered new jobs in a different city. A real estate broker sent them a listing of apartments in their desired location, showing the square footage in each apartment. In other words, this is the size of each apartment. Use linear regression analysis to determine if there is a correlation between the square footage of rental property and the amount charged for monthly rent. What is the linear regression equation? And interpret the correlation coefficient. So here we've created a table. The left column indicates square footage of each apartment. In other words, how big each apartment is. The right column indicates the monthly rent for each of those apartments. So on the left, we got square footage. On the right, we got the corresponding monthly rent. Now, I took the information from this table of square footage and monthly rent and plugged it into Desmos to get a scatter plot, which you can see right here, okay, where all the dots are. That indicates all the bits of information from the table. I then used Desmos to take and estimate a linear regression equation, and I came up with this for my linear regression equation. In addition, Desmos told me what the correlation coefficient was. That's R over here, which is almost 9. It's 0.96. So what is this telling me? Well, the fact that R is so close to 1 indicates that there's a very strong correlation here, that as square footage increases, monthly rent correspondingly increases in a linear fashion, okay? And that's what this equation for the straight line that approximates the data that we see in the scatter plot. Now, let's look at another aspect of Rufus and Maria's desire to move to a new city. And if they decide to move to the new city and rent the apartment, specifically they're looking to rent the 1,150 square foot apartment in example 2, they're going to have to pay a $200 application deposit. In addition, they are required to provide a credit report that costs $25, and pay a security deposit equal to 1 month's rent. The landlord also requires the last month's rent at the same time as signing the lease. Finally, the broker charged 10% of the yearly rent. How much should they expect to be able to pay? How much should they expect to pay to be able to move into the apartment? So when they move into the apartment, how much is it actually going to cost them out of pocket? So I've taken each of these expenses and added them up. I've got my application deposit of $200. I've got the credit card report fee of $25. I've got the security deposit, which is 1 month's rent. I've got last month's rent. I've got the broker's fee. Now remember, the broker's fee is based upon a year's rent. So I have to take the monthly rental, multiply it times 12, and take 10% of that to get the broker fee. And then lastly, the first month's rent as well. And if I add all those up, I find that Rufus and Maria have to pay $6,924 before they can move into the apartment. Now here's another example. This involves moving expenses. Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he will need more movers' time to pack, load, unload, and unpack, because his friends will not be able to help him. If he moves on a weekend, however, he can get his friends to help, cutting down on the number of hours he will need to hire movers. Move Out is a moving company that supplies movers, trucks, and moving equipment. They have given him the following moving estimates. Notice, on the left here, we have a weekday move, all right? And the weekday move indicates that he will require 6 hours for loading and unloading, 5 hours of packing and unpacking, or a total cost of $720. In addition, they gave another estimate for a weekend move. Remember, on a weekend, Jay can have his friends come and help, which means that the moving company can cut down on their loading and unloading hours to 4, and their packing and unpacking hours to 2, and require a payment of only $400 instead of the $720. Move Out charges a set hourly moving team rate for loading and unloading, and a different set hour moving team rate for packing and unpacking. Determine the Move Out hourly rates. Okay, so what I've done here is I've taken each of the estimates that the moving company gave. First of all, for a weekday move, with 6 hours of loading and unloading, 5 hours of packing and unpacking, for a total cost of $720. So I've said 6 times X. X represents the hourly rate for loading and unloading, plus 5 times Y, which is the hourly rate for packing and unpacking, and that is equal to 720. So that's this equation right here. Now, I've also looked at their figures for a weekend move. In this case, it's only 4 hours for loading and unloading, 2 hours for packing and unpacking, and a total cost of $400, which comes out to be an equation of 4 times X plus 2 times Y is equal to 400. Now, I want to find out what X and Y are equal to, because that's going to be their hourly rate for loading and unloading, which is one rate, and for packing and unpacking, which is the other rate, or Y. So I've, again, used Desmos. I have graphed both of these equations, this one and this one, and I see where they intersect. And where they intersect is where X is equal to 70 and Y is equal to 60. Well, what is this telling me? This is basically telling me that their charge for loading and unloading is $70 per hour, which we got for the solution for X, and $60 per hour for packing and unpacking, which is the solution for Y. Okay, so here's another example. Samantha is moving from Madison, Wisconsin to La Crosse, Wisconsin. She will do all of the packing and unpacking by herself with her brother, okay? So she's going to do everything by herself and her brother. The moving company quoted a price of $1,250 for 8 hours of loading and unloading and driving 130 miles from Madison to La Crosse. The company quoted the same price, okay? They quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother. Samantha figures that with her brother's help, she only needs to hire the movers for 6 hours. Remember, the moving company originally quoted 8 hours. How much does the company charge per hour for the loading, unloading? How much do they charge per mile for driving? Okay, so what I've done is create a table here. And one of these shows the amounts of hours for loading, unloading, and mileage when her brother was not included, okay, and what the cost was. Notice the cost was quoted as the same for both. Okay, But with her brother, the loading and unloading hours is less. It's now 6 instead of 8, but the mileage is more because it's 160 miles. So the total cost was the same for both of these, but in one case we had 8 hours plus 130 miles, and in the other case we had 6 hours plus 160 miles. So what do we have here? We know that the labor cost for loading and unloading plus the truck rental cost is going to end up equaling the total cost. So we've got our loading, unloading right here. That's the labor cost. We've got our mileage right here. That's the truck rental cost. And they both end up being the same over here on the right of the total cost. Well, you can see that with the brother and without the brother, we can create two equations here, okay? Based on 8 times the cost for loading and unloading, plus 130 times y, and y is the cost per mile for the truck rental. So in the top case, we've got 8x plus 130y is equal to 1250. And in the second case, when we have 6x plus 160y is equal to 1250. And I have to apologize here because these are reversed. Okay, the top one should be without the brother, and the bottom one should be with the brother, because when she has the brother, she has less hours that she has to take and pay the movers. So don't forget, these right here are reversed, okay? So that was my error, that the top should be without brother, the bottom should be with brother. So we can take these two equations and we can either graph them and look where they intersect, or we can solve them simultaneously. Remember from algebra how you solve simultaneous equations, and we come out with x is equal to 75 and y is equal to 5. Well, what does that mean? Basically, what that is saying is that Samantha will pay $75 per hour for loading and unloading and $5 per mile for the truck rental. So that's the cost that the moving company will charge her.